In this video, you are going to be learning how to solve rational equations and how to use rational equations to solve problems. So far we have learned how to simplify, we have learned how to multiply and divide rational expressions, how to add and subtract rational expressions, and now we get to solve rational expressions. So here you go. In the last video, we discussed how to add and subtract rational expressions by coming up with a common denominator. Now, the cool thing about this is here's what you're going to do. You're going to still, again, figure out what that common denominator is. But instead of keeping that denominator all the way through your equation, you're actually going to multiply the entire equation by that common denominator. So, for example, the common denominator, let's see, there's an x, so I know an x is going to have to be part of the denominator that you would have tried to find common. You have a 2 and a 5, so the least common multiple of 2 and 5 would be a 10. So I know that I'm going to multiply the entire thing by a 10 times x. Why x? Because it's in the denominator, and why 10? Because both 2 and 5 go into 10. So here is what you do. You are going to multiply this 10x by each fraction. But first, you're going to figure out what reduces. So, x goes into x 1 time, 2 goes into 10 5 times, so 5 times 1 is 5. This x and this x cancel, and 5 goes into 10 twice, so 2 times 2 gives you 4. This 2 goes into 10 5 times. There was no x to cancel, so you're left with 5x. 5 minus 4 is 1. And to solve for x, you divide both sides by 5. So x equals 1/5. Now, I'm going to show you that in another way to show you why that works. Again, I'm going to distribute 10x times 1 is 10x all over 2x. 10x times 2 is 20x, and then bring down the 5x. 10x times 1 again is 10x, and you have a 2 on bottom. And now you can reduce. 10x divided by 2x is actually the number 5 because the x's cancel and 10 divided by 2 is 5. The x's again cancel, and 20 divided by 5 is 4. Here, only the 2 goes into 10 5 times, the x does not cancel, leaving you 5x. And that is actually the exact same thing that you get there. The first way I did it is I, in my head, figured out how to reduce it. The second way is I just multiplied by the numerators and then saw what canceled. Either way will get you to the same answer. So let's try to do one. So for example, in this case, I have an x, so I know I'm going to have to multiply by x. I also have an x plus 2, so I'm going to have to multiply by an x plus 2. There is no denominator here, and so I do not have to worry about that. So now let's look. So one thing, the first way I can do it is I can go ahead in my head and see what cancels. The x and x cancel, leaving me the 15 and the x plus 2. In this case, the x plus 2 and x plus 2 cancel, leaving me the x times 9x minus 7. Here, nothing canceled with the denominator, leaving me the 9 times the entire thing. So basically, I'm taking this and I distributed and only wrote what didn't cancel. So now I'm going to simplify. 15 times x is 15x. 15 times 2 is 30. X times 9x is 9x squared. And then 7 times x is negative 7x. 9x times x is 9x squared. And 9x times 2 is 18x. And now we are going to solve this really long equation. So the first thing I'm going to do is go ahead and subtract 9x squares on both sides, and nicely, they both cancel. leaving me 15x and negative 7x give me 8x on the left-hand side and a positive 30, and a positive 18 on the right-hand side. So to solve, I'm going to subtract 30, which gives me a negative 12, divide by 8, and I get negative 12 over 8, which gives me negative 3 over 2. And that would be my answer. Now, the other way to have done this is when I distribute this x plus 2 times x, I'm going to go ahead and just write that over the original denominator. Same thing here. 9x minus 7 times x plus 2 all over x plus 2 equals, distribute, I'm going to get 9 times x times, I'm running out of room. Times x times the x plus 2. So now I notice that x and x cancel, leaving me the 15 times x plus 2. Here, the x plus 2's cancel, leaving me the x times 9x minus 7. Here, nothing canceled, and so I actually have the entire thing left over. And if you notice, this entire equation is the exact same equation over here. So again, it does not matter which way you want to do this, you will still get the exact same answer. So let's practice with another type, and something happens at the end that I want to show you. So again, first, let's factor what we know. B squared minus 1 is b plus 1 times b minus 1. Now, to find a common denominator, b plus 1 is in the denominator, so we're going to have to multiply by that. Next, b minus 1 is also in the denominator, so we're going to multiply. And then here, we already have the b minus 1 written, and here we already have the b plus 1 written, and so we don't have to write again because it's already there. So, the b plus 1's cancel here, leaving you 1 times the b minus 1. Here, the b minus 1's cancel with each other, leaving you 1 times the b plus 1. And here, they both canceled, b minus 1 and b minus 1, b plus 1, b plus 1. They both canceled, leaving you just a 2. So if I was to solve this, I would have b minus 1 plus b plus 1 equals 2. b plus b is 2b. Negative 1 and 1 give you 0, leaving you 2. And your answer b equals 1. Now, normally I would say, you're done, you found b. However, in the past we have discussed extraneous solutions. If I was to plug 1 back into your original problem, what happens when I plug 1 back into b here? I get 1 minus 1, which is 0, which is a 0 in the denominator. And you can't have a 0 in the denominator. So therefore, that cannot happen because you cannot plug 1 back in. And so your answer actually becomes no solution. So you will have to check your answers. And you're going to ask, why didn't you check them earlier? Well, I could have. I just happened to notice that negative 3/2 did not create a 0 down here. And 1/5 didn't create a 0 down here. And so just in my head, I happened to notice that. But in this case, I saw that 1 actually was going to give you a 0 in the denominator. And so that is why you have to be careful about extraneous solutions. So to recap, I would like for you to pause the video, attempt these problems, and then resume when you're ready to see the answers. Okay, for the first one, I need to factor this part out to see what I get. Oh, which is nice because it happens to be very close to the other denominator. So I have an x plus 3. I'm going to have to multiply everything by an x plus 3. I have an x minus 4. I'm going to have to multiply it by everything minus 4. This x minus 4, I already have it up here, so I don't have to write it again. And x plus 3, I already have it up here, so I don't have to write it again. So what's going to happen is when I distribute, the x minus 3 and x minus 3 cancel each other, leaving you a 2 times the x minus 4. Here in the second fraction, the x minus 4's cancel, leaving you a 3 times x plus 3. And in the last part, both the x plus 3 and the x minus 4 cancel each other, leaving you just your numerator. And now you have an equation that you can solve. So you have 2x minus 8 plus 3x plus 9 equals 2x minus 2. 2x and 3x give you 5x. Negative 8 and 9 give you a 1. So now to solve, I'm going to subtract 2 and I'll get 3x. Subtract 1 and I'll get negative 3. So I'll get x equals negative 1. Now, check to make sure that's allowed. If I plug negative 1 in here, I don't get a 0. I don't get a 0. Don't get a 0. Don't get so it worked. You can actually get negative 1 for an answer. It gave you something that won't give you 0 in the denominator. So you're good. On this next one, that fraction, okay, so I have an x plus 1, so I'm going to have to multiply by a k plus 1. Second is a k minus 2. I don't have it already up here, so I have to multiply by k minus 2. So now when I distribute, in the first fraction, the k plus 1's cancel, leaving you k times k plus 2, k minus 2. In the next one, the k minus 2's cancel, leaving you k times the k plus 1. And then here, nothing canceled, so you actually are going to have to multiply by the k plus 1 and the k minus 2. So I'm going to distribute. I'll get k squared minus 2k plus k squared plus k equals 2 times k squared minus k minus 2. If you FOIL that, you would get that. So to solve, k squared plus k squared is 2k squared. Negative 2k and a positive k is a negative k. And I'll distribute this 2k squared minus 2k minus 4. Okay, first thing I'm going to do is subtract 2k squared from both sides. And they nicely cancel each other, leaving you negative k equals negative 2k minus 4. I'm going to add 2k to both sides, and I'll get k equals negative 4. And that would be your answer. And now you need to check. If you plug negative 4 back in, you don't get a 0 here, you don't get a 0 here, which means that that answer is possible.